Welcome back, mathematicians. In this video, we are going to work through trigonometric identities. Two functions are considered identically equal if f of x is equal to g of x for every value of x for which both functions are defined. So below we have some basic or fundamental identities that have already been established, and we're going to use these in order to establish other identities. We have the quotient identities, which is tangent of angle theta is equal to sine of angle theta over cosine of angle theta, and cotangent of angle theta is equal to cosine of angle theta over sine of angle theta. Next, we have the reciprocal identities, which is secant of angle theta is equal to 1 over cosine of angle theta, cosecant of angle theta is equal to 1 over sine of angle theta, and cotangent of angle theta is equal to 1 over tangent of angle theta. Finally, we have the Pythagorean identities, where we have sine squared of angle theta plus cosine squared of angle theta is equal to 1, tangent squared of angle theta plus 1 is equal to secant squared of angle theta, and cotangent squared of angle theta plus 1 is equal to cosecant squared of angle theta. I'm going to focus on the first one because we can actually subtract terms to both sides of these Pythagorean identities to get different versions. So for example, if I subtract cosine squared of angle theta to both sides, it results in sine squared of angle theta is equal to 1 minus cosine squared of angle theta. Likewise, we can also subtract sine squared of angle theta to both sides, and as a result we get cosine squared of angle theta is equal to 1 minus sine squared of angle theta. Because of the fact that the right side of these new variations matches the difference of squares formula, we can also rewrite this as 1 plus cosine of theta times 1 minus cosine of theta, and the second one we can rewrite as 1 plus sine of theta times 1 minus sine of theta. That first Pythagorean identity is the one that you will likely use most often, and so I just wanted to show all the different variations you might see with that one Pythagorean identity. When establishing an identity, there is not one particular set of rules or tips or steps that will work with every single identity. As a result, here are some suggested general strategies that you should consider when working to establish an identity. Number one, start with one side of the given equation, usually the more complicated side. The part here that we all need to do is starting with one side of the given equation. We never work from both sides, just one side. But you can pick either side to work from, but we generally pick the more complicated side because it's easier to simplify a more complicated side. Number two, we might use any of the following algebra techniques, which could include, but are not limited to, factoring expressions, using the distributive property, and combining fractions. We will likely substitute using the fundamental or basic identities we've already discussed. And finally, sometimes we like to rewrite in terms of sines and cosines because we tend to be more familiar with sines and cosines. Let's now look at an example where we are asked to establish the identity. We're given cosecant of angle theta times tangent of angle theta is equal to secant of angle theta. Now, what we are not trying to do is solve this equation for angle theta. What we know is that theta can be any angle in the domain of cosecant, tangent, and secant. That means that this is an infinite set of angles that satisfy this equation. What we are trying to do is establish that the left side is actually equal to the right side. Let's start by working with the more complicated side, which is cosecant of angle theta times tangent of angle theta. What we know, based on the reciprocal identity, is that cosecant of angle theta is equal to 1 over sine of angle theta. We also know, based on the quotient identity, that tangent of angle theta is equal to sine of angle theta over cosine of angle theta. Now let's go ahead and multiply our two fractions together, and the result is sine of angle theta over sine of angle theta times cosine of angle theta. Now we will simplify the fraction by reducing by a common factor, which is sine of angle theta. This now gives us the ratio of 1 over cosine of angle theta, which we know is equal to secant of angle theta, also based on a reciprocal identity. So we have now shown that cosecant of angle theta times tangent of angle theta is equal to secant of angle theta. Let's now look at the example where we are given cosecant of angle x minus cotangent of angle x is equal to sine of angle x over 1 plus cosine of angle x. Now we could probably argue which side is the more complex side. I'm going to work from the left side because it has more terms in the expression, which I will try to simplify to be that single fraction that we have on the right. So let's rewrite this as cosecant of x minus cotangent of angle x. What we know is that cosecant of angle x is equal to 1 over sine of angle x based on the reciprocal identity. We also know that cotangent of angle x is equal to cosine of angle x over sine of angle x based on the quotient identity. We now have two fractions with a common denominator, which we will rewrite as one single fraction, which is 1 minus cosine of angle x over sine of angle x. Now this seems to be almost flipped what I'm trying to get as a result, the difference of course being that I have 1 minus instead of 1 plus cosine of angle x. To solve this issue, I'm going to go ahead and multiply by what we consider a well-chosen 1. A well-chosen 1 simply means that the numerator of this fraction I'm about to write must be exactly the same as the denominator of the fraction. I'm going to multiply by 1 plus cosine of angle x over 1 plus cosine of angle x. You'll notice that this is the conjugate of the numerator 1 minus cosine of angle x. So once I multiply that out, I get 1 minus cosine of angle x times 1 plus cosine of angle x over sine of angle x times 1 plus cosine of angle x. Now I'm going to use the distributive property and simplify the numerator, and I will get 1 minus cosine squared of x over sine of x times 1 plus cosine of x. Now you'll notice I've achieved my goal, and I now have 1 plus cosine of angle x in the denominator, but I also have sine of angle x in the denominator as well. So what I will do next is replace 1 minus cosine squared of angle x with sine squared of angle x, and I can do that based on the Pythagorean identity. This is over sine of angle x times 1 plus cosine of angle x. Now I have factors of sine of angle x in my numerator and denominator. Sine squared of angle x really means sine of angle x times sine of angle x, and this is over sine of angle x times 1 plus cosine of angle x. So now I'm going to go ahead and reduce by that common factor, and so what I get for a final answer is sine of angle x over 1 plus cosine of angle x, which is the result I'm looking for. All right, guys, good luck.